All right, today we're going to try to tackle a question that our brains, well, they just weren't built to answer. Just how big is the universe? To even begin to wrap our heads around it, we're going to need a whole new way of looking at things. So we're going on a journey right to the edge of reality itself to find that perspective. Let's dive in. So to get us started, I want you to just think about this for a second. Really picture it. A single tiny grain of sand in the palm of your hand. Now imagine that's our sun. Got it? Okay, so if that's the sun, how big do you think our galaxy, the Milky Way, would be? Go ahead, take a guess. Just lock that answer in your head. We'll come back to it, I promise. This little thought experiment, it really gets to the heart of the problem we're facing. And here's the core issue, right? Our brains are amazing, but they evolved to understand things on a human scale. We can guess the distance to that tree over there. We can sort of feel the size of a city. But the universe, it doesn't play by those rules. It doesn't work in miles or kilometers. It works on a scale so ridiculously vast that our gut feeling, our intuition, just completely and utterly fails us. So if our minds aren't naturally equipped for this kind of journey, what do? Well, we have to build the tools ourselves. And that's exactly what we're going to do right now. We're going to construct a kind of mental ladder, starting right here in our own backyard and climbing up, rung by rung, to the biggest scales we can possibly imagine. Okay, let's take that first step up our ladder, because before we can even think about galaxies and these massive superclusters, we have to get a feel for our own little cosmic neighborhood. And to do that, we're going to need a whole new ruler. So forget kilometers. They're basically useless from here on out. Our new measuring stick is the light year. It's the distance that light, the fastest thing in the entire universe, can travel in one single year. That works out to about 9.5 trillion kilometers. I mean, it's a number so big it's almost meaningless on its own, but trust me, it is the essential first rung on our ladder. Using this new ruler, the closest star to us, our nearest neighbor, Proxima Centauri, is 4.24 light-years away. Now, to put that into perspective for you, if we took our fastest spacecraft and pointed it in that direction, it would still take tens of thousands of years to get there. And that's just to get to the house next door. Okay, you ready? Let's take a huge leap up the ladder. 100,000 light years. That is the diameter of our home, the Milky Way galaxy. It's this sprawling city of anywhere from 100 to 400 billion stars, every single one of them a potential sun, many with their own families of planets. That little 4.24 light-year trip we just talked about, that's like walking to the mailbox in a city that spans an entire continent. And here it is, the answer to that question from the beginning. If our sun is just one single grain of sand, the Milky Way isn't the size of a beach or a park or even a city. It would be a giant circle stretching for hundreds of kilometers, an area bigger than some countries, just filled with sand. That is the kind of scale we are dealing with, and we're still just inside our own galaxy. But of course, it doesn't stop there. Our galaxy isn't just floating alone. No way. It's actually part of a structure that is even more mind-bogglingly enormous. It's time to climb a little higher and see how all these galactic islands come together to form what's called the Great Cosmic Web. Our Milky Way, along with about 100,000 other galaxies, belongs to a supercluster. Its name is Laniakea. This colossal structure, this massive collection of galaxies and galaxy groups, stretches over 500 million light-years. Everything we've seen so far, from our sun to the edge of the Milky Way, is just one tiny, tiny neighborhood inside this single thing. And even these superclusters aren't the end of the line. They're all connected by these long, thin threads made of galaxies, stringing through space like a giant spider's web. And in between all those threads, there are these huge, almost completely empty voids. The largest of these web-like structures we've ever found, a colossal wall of galaxies, is a staggering 10 billion light-years from one end to the other. And here we are. We've made it to the top of our ladder, at least for now. 93 billion light-years. This is the estimated diameter of the observable universe, the largest scale we can currently measure. It's the bubble that contains everything we've just talked about. But did you notice that word I just used? The observable universe. That one little word is so important because it implies there's an edge, a boundary to what we can see. So the obvious question is, what's beyond that edge? See, this 93 billion light-year sphere, it isn't a physical wall you could bump into. It's a horizon in time. The universe is about 13.8 billion years old, right? So that means we can only see light that's had 13.8 billion years to travel across space to get to us. Anything further away than that, well, the light from it just hasn't reached us yet. It is, for now, completely invisible. And this leads to a really profound, kind of mind-bending idea. The observable universe is just the part of the fishbowl we can see. But the total universe, the whole thing, is almost certainly much, much bigger. In fact, for all we know, it could be infinite. Our entire cosmic web, our whole 93 billion light-year bubble of reality, might just be one tiny, insignificant patch in a cosmos that literally goes on forever.
And if that wasn't enough to humble you, here is the final cosmic kicker. Everything we've been talking about, every star, every galaxy, every planet, you, me, this screen, it's all made of what scientists call normal matter. And all of it, makes up a measly 5% of the known universe. The other 95%? It's made of dark matter and dark energy, mysterious forces and substances we can't see and we barely understand.
Wow. Okay, after a journey like that, it's pretty easy to feel, well, small. So let's bring all of this incredible perspective all the way back home. What does seeing the true scale of everything really mean for us, right here on our tiny little planet?
I don't think anyone has ever captured this feeling better than the great astronomer Carl Sagan. He described our Earth, as seen from billions of kilometers away by the Voyager spacecraft, as just a pale blue dot, a lonely speck in this great enveloping cosmic dark. He said all of our history, all our triumphs and tragedies, our wars and our art, it all happened right there on a mote of dust suspended in a sunbeam.
And that's really the ultimate takeaway, isn't it? This cosmic perspective, it isn't meant to make us feel insignificant. It's meant to give us context. It gives us a really deep sense of humility, a boundless curiosity to learn more, and a powerful, powerful sense of shared responsibility for this planet, the only home we have ever known. So I'll leave you with this question. After seeing this sheer, mind-breaking scale of everything, from our neighboring stars to the cosmic web, and whatever lies beyond, what does this perspective change for you?